All right, so in this video, we're going to look at the ratio test. And for the ratio test, it works well with any series, honestly. Um, I uh, I think it works the best when you see like those factorials or exponentials, like when you have like 5 to the k or like something like k factorial. So it says that if you compute the limit as k approaches infinity of a k plus 1 over a k, this is equal to L. Don't worry, Alvin. I'm recording this, so as soon as I finish the workshop, when I get home tonight, I'm definitely posting this on YouTube, so you'll be fine. Okay. So that's our that's my quick thing about ratio tests is that it works well with the exponents and factorials. For this limit, however, if it exists and is equal to L, if L is less than 1, then we say that the given series converges absolutely. If L is greater than 1, then the series will diverge. If L is equal to 1, it's inconclusive, and you have to use some other tests. Okay. So the example that you would like to go over is the following. Let's say if we had the series from k equals 1, I believe, of -1 to the k plus 1 power times 5 to the k. No, is it 5? Yeah, 5 to the k power. So I wrote this incorrect. There should be 5 to the k, all divided by k factorial. So when you look at the series, first thing that you should recognize or try to pinpoint is what's my AK? What's my sequence? So any volunteers? What's my sequence here? That's right. Your sequence is going to be 5k over k factorial. Now, you're technically, if you look at this as your first term, then the a k plus 1 term is going to equal to 5 raised to the power of k plus 1 over k plus 1 factorial. So what I need to do is take the limit as k approaches infinity of the absolute value of ak plus 1 over a to the k. And we got to compute it, see if it exists. So the limit as k approaches infinity of ak plus 1 over ak. So you make some substitutions here. You're going to get the limit as k approaches infinity of the numerator should read as 5 to the k plus 1 over k plus 1 factorial. And all of that is divided by the original sequence, 5k divided by k factorial. Okay. Now we got to compute this limit. Oops, sorry. So I have to do some simplification inside of that absolute values there. So the first part, I'm going to leave it alone for now. I'll call it 5 to the k plus 1 over k plus 1 factorial. That I'm going to leave alone. I'm going to change division to multiplication. And I'm now going to multiply by the reciprocal, which is k factorial over 5 to the k. All right. Now what I'm going to do is rewrite a to the sorry, I'm going to rewrite the a k plus 1 sequence. So when I have 5 to the k plus 1, remember that plus 1 is in the exponent. And you can actually break that down as saying 5 to the k times 5, right? So you have 5 to the k times 5 or 5 to the first, right? If you recall in pre-calculus or algebra, as long as the bases are the same, you add the exponents, right? So we're looking at 5 to the power of k plus 1 backwards to give us 5 to the k times 5, right? Now, for your denominator, k plus 1 factorial, when you deal with factorials, it's just a product of decreasing positive integers. So if that number, for example, k plus 1 was 5, then the next number would have been 4, then 3, then 2, then 1. So in short, when you want to factor the k plus 1 factorial, it would factor as k plus 1 times k factorial. Because again, think about it. Let's say if I chose the number 9 now, k plus 1 is equal to 9. That means that the next number that would come after in the factorial would be 8. And then you'll have 7, 6, 5, 4, 3, 2, 1. So you can summarize that product 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 as just simply 8 factorial. So in general, if you see k plus 1 factorial, you pull out the k plus 1, you have k factorial remaining. Okay, now I'm just going to rewrite all the good stuff, the k factorial and the 5 to the k. And we're looking at the limit as k approaches infinity. So good things happen here. Things can cancel out. Notice that in the numerator, there's a 5 to the k, and there's a 5 to the k in the bottom, so they're gone. There's a k factorial in the numerator, and there's a k factorial in the bottom, so they're also gone. Therefore, we have the limit as k approaches infinity of the absolute value of 5 over k plus 1. So as you compute this limit, as k goes to infinity, this limit is going to equal to what number? 0. And now let's compare that to 1. Is 0 less than or greater than 1? 0 strictly less than 1. So that symbolizes, or that implies that the given series that we began with will converge absolutely. And we just have to write that statement. We say that the given series will converge absolutely by the ratio test. And we're done. That would be the solution to example 1. I have 6 minutes. Let me just do a second example. And then I'll stop the recording and then I'll let you take some more notes. Or maybe I could zoom out. So can I zoom this? Can you still see the screen? I'm done. Oh, you're done? All right, I'll just leave it the way it is. That's fine. Let's look at an example 2. Real quickly. Something very similar. Let's say that now I have, we want to test for convergence here. We have k equals 0 to infinity of -1 to the k power times k factorial over e to the power of k. So, Ms. Vo, what would be my AK here? That's right. You have k factorial over e to the k. Now, what would be AK plus 1? That's right. So you have k plus 1 factorial over e to the k plus 1. So now we're going to apply the ratio test. We're going to take the limit in this example. We're going to compute the limit as k approaches infinity of k plus 1 factorial over e to the power of k plus 1, all divided by k factorial over e to the k. And what you're going to suspect when we compute this limit is that you're going to have to do some rewriting, right? So for the numerator part, I am going to first rewrite it. I know that k plus 1 factorial is the same thing as saying k plus 1 times k factorial. And then the e to the k plus 1 is just e to the k times e to the first power. I am going to now multiply that. So I'm changing division to multiplication. And I am going to take the flip of our denominator. So I'm going to flip this guy. So k factorial over e to the k is now going to be e to the k times k factorial. And we can simplify this. What would cancel out? We'll have the k factorials canceled, e to the k's are canceled, and you're going to get, oops, sorry, the limit as k approaches infinity of the absolute value of k plus 1 over e. As k goes to infinity, then you're going to have infinity plus 1 over e. So what would this equal to? Infinity. And what do we know about infinity? Is it less than, equal to, or greater than 1? It's definitely greater than 1. So because we're going to get infinity as a solution for the limit, which is greater than 1, then we can say that by the ratio test, the given series diverges. And that's it. That's how you apply the ratio test.